if I talk about guys error detection, then what is error? Before error detection, let us talk about what is error. According to the definitional point of view guys, a condition when the receiver's information does not match with the sender's information, it is called as error. What error means? Whatever sender has sent is not exactly taken by the receiver. Receiver has taken something else. That is called as error. Okay guys. During transmission, digital signal suffers from noise. They can introduce errors in the binary bits traveling from sender to receivers. Maybe thunderbolts will be there, maybe electrical fluctuations is there, due to which some binary digits may get changed. That means that 0 bit may change to 1 or 1 bit may change to 0. Suppose your data is 1110101 like that, and it is changed to 01101 like that. So due to electrical fluctuations or maybe due to some other reasons, thunderbolts, your data is changes from this to this. Suppose sender has sent this data, but receiver has received this one. So this kind of errors which you will got between sender and receiver are termed as error. Okay, it is a basic definitional point of view. Now there are two types of things. That one is packet loss. Suppose your packet is there and this packet is lost. Why your packet get lost? Suppose your router is there and in this router is having too much load. Maybe due to too many packets are there, maybe due to congestion. So due to that packet may get lost. Or another thing is that you have a packet is not lost, but the data of this packet gets changed. You will call it as bit get changed. Bits get changed. Maybe due to thunderbolt or maybe due to any electrical fluctuations, power on off power fluctuations like that, voltage instability or whatever may be the reason. So there may be packet loss, there may be bit gets changed. Due to that, receiver will not get the data exactly what sender wants to send. This is called as an error. This is the basic point of error. Now for error detection are placed under error handling. Basically before error detection, the topic which came is error handling. In error handling, there is an error detection. In error handling, there is an error detection and error correction. In error handling, we have error detection and error correction. In error detection, what process happen? In error detection, computer basically knows that there is an error. Computer basically knows there is error, but it don't know that where error is. Right, it only know that there is an error, but it don't know what it don't know, that where error is. It can't correct it. This is placed under error detection. If we talk about error correction, your computer know there is error. Your computer know itself, it can correct also. It is placed under Hamming code. Which is part of all the computer syllabus, which I think you should have the knowledge of it, because in newly added subjects we only have the topic error detection. So we are discussing error detection here. Now when we detect or computer will detect any kind of error, the only possibility is retransmission. In error detection, if you find that there is an error, it is 100% sure, but you can't correct it. but you can't correct it. So what is the possibility of solution of that? The only solution we have is retransmit the packet. You can consider it with the real example, like when you create a Gmail account, they ask for a password to you, and they also ask one more password to create your password. They just want to reconfirm your password. So in first position, suppose you have typed some password which will be reflected in dot 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 to you. They will another time they will say that please retype it, so that they can confirm that your both passwords are matching or not. So you will again rewrite that password. But suppose you have rewritten first password as a wrong. So computer don't know that whether this password is correct or this password is correct. But computer know what it know that there is an error between these two. Computer knows that there is an error between these two passwords, but it don't know that whether password 1 is incorrect or password 2 is incorrect. That is why it will say that please retype again, and you need to retype in both the column again. In both column you need to rewrite again, because computer itself say that yes, we find error because both passwords are not matching. But it itself don't know that whether password 1 is correct or password 2 is correct, or both are incorrect. That is why it will ask you again to retype, because it don't know that whether password 1 is incorrect or password 2 was incorrect. This is the same problem as of error detection. In error detection also, whatever sender is sended and whatever receiver is received, error will got detected like this, but computer don't know that where error is exactly. That is why the only medium to solve this problem is retransmission, means you need to retransmit the whole data again, right? It is the concept of error detection. Okay guys, okay, Ashik is asking for previous slide. This is the previous slide, Ashik. Please take a fast screenshot of it. Please take a screenshot of it so that I can move forward. And for all other candidates, have you got it that what error detection is all about? Means we can detect the error, but we can't detect where error is exactly. Are you got the basic concept of error detection, guys? Are you got basic concepts? Okay. Now, if I talk about error detection in somewhat detail, I need some space here now. Okay. So just 2 seconds, guys. Okay. So in error detection, first kind of error detection would be like retransmit the data again. What first solution is? First solution is retransmission of complete data. Retransmission of complete data. It is the first solution. But in that solution, what problem we are facing? In that solution, we are facing that suppose your first data is consisted of 1 billion bits. Right? So suppose only one bit is get changed. Only one bit is get changed. So to correct only this one bit, we will again need to retransmit one more billion bits. Isn't it? Because in the first 1 billion bit, only one bit is changed. Suppose only one bit is changed. And due to that, our information is processed to the receiver as a wrong information. So to correct that one bit, to detect that one bit, we again need to retransmit. So there is a need of transmission of 1 billion bits again. So this is not to be accepted in computer networks. This is not a practical use, and this is not practically used. This is not practically used because efficiency will be get lost of our computer network. That is, we will not go for the retransmission again for the whole data. Then what we will do, we can do CRC, that is cyclic redundancy check. We are going to this topic in very detail with all important questions that you may face in your GATE exam. And next question, next solution is checksum. There are two more other solutions like VRC, vertical redundancy check, and LRC, logical redundancy check. But VRC and LRC are basically completely theoretical. No logic is there, just theory is there. So I will share the screenshot of there to you in the WhatsApp group. In our WhatsApp group, I will share the screenshot of VRC and LRC to you. But the most weighted topic according to the Med Easy faculty of the GATE 2021, they have mentioned CRC and checksum. In that also only CRC they have mentioned as the most weighted topic. Means they have said that if examiner have to ask any question from error detection, the first choice of examiner would be on the CRC, that is on cyclic redundancy check. It would be his or her choice or for GATE. Very important, and it is most used practically in IT industry as well. That is why our complete focus will be all around CRC concepts, right? And all other concepts I will discuss with you, but for VRC and LRC I will send the screenshots of the theory, or I will share the PDF with GATEFORUM admin. They will share that material with you. But for our GATE, because we are focusing on completely on GATE, they are subjective topics, VRC, LRC. But for the perspective of GATE, what our focus is? Our focus is to get marks in GATE exam. Our complete focus will be all around GATE exam, that how to get maximum marks in GATE. So we will solve some practice questions on CRC because it is most weighted topic. And ISRO and BARC is also asking some questions already in CRC. So I will give that question to you after discussion of the CRC, and then we will solve that. So error detection is, there is an error in receiver side that is getting different data from the sender side. So to detect that, there is a first method, that is retransmission, which is very typical, very difficult and very lengthier and very uncostly for us, not economical. That is why it is not practically used. So we go for CRC. Now first we will discuss some theoretical points. After these theoretical points, I will go into the practical example, and then we will solve some important questions on it. So if I talk about cyclic redundancy check, that is CRC. First one is, unlike checksum scheme, okay, we don't know checksum scheme, we will discuss checksum scheme after it. It is based on addition. CRC is based on binary division. I will tell you an example, and after that we will gonna discuss that. In CRC, a sequence of redundant bits called cyclic redundancy check bits are appended to the end of the data unit so that the resulting data unit becomes exactly divisible by a second predetermined binary number. What I am telling this, you will get it with this example. For example, my sender have a data 1011011. It is my data, or it is the data sender have, and it wants to send this data to receiver. So in order to check at the receiver's end that whether our data is got exactly what sender has sent or not, we use CRC. In CRC we use CRC generator bits. Some CRC generator we use. CRC generator is some bits, like suppose I use 1101. It can be any bits. It can be 1001, whatever it bit. The knowledge of CRC generator will be on the sender part. Sender also know that what CRC generator is, and receiver will also know that what CRC generator is. So I use 1101 as a CRC generator. Now this CRC generator is 1101. Basically it is of 4 bits. This CRC generator is consisted of 4 bits. So just one bit less, that is 3 bits. I will append 30 to the right hand side of this. Means you can see here, I will add 3 zeros as a appended bit with my data. This is my complete frame now. In my frame, I will add 3 zeros as a appended zeros. Why I add 3 zeros? Because in CRC generator, I have 4 bits. So I will just subtract 1 bit, means I will add 3 bits, 30 bits. I will call it as a appended bits. Appended bits here in my data. Why I am adding it? I am telling you the concept of CRC. Once I will discuss complete concept with you, you will get clear. Suppose I have n bits. Suppose I have n bits in my CRC generator. In my CRC generator, I have n bits. Then how many zeros I will append it here in the right hand side of this sender's data? I will add n minus 1 0 bits as a appended bits. If I have n bits as in CRC generator, then I will add n minus 1 0 bits as a appended bit. Okay guys, now this is the point that in CRC generator a sequence of redundant bits called cyclic redundancy check bits or CRC generator bits are appended to the end of data unit so that the resulting data unit become exactly divisible by second predetermined binary number. This is the point. The next point is at the destination the incoming data unit is divided by the same number. If at this step there is no reminder, the data unit is assumed to be correct and is therefore accepted. What is this? Focus again here. What is this I am talking about you now? Focus again here. So how many appended bit I have added? 3 appended bit, that is 3 zeros I have added as appended bit. So I now need to calculate CRC bit. What are my CRC bits? Now I need to calculate. These are my CRC generator bits and these are my appended bits. Now I need to calculate CRC bits. What I need to calculate guys? I need to calculate CRC bits. How I calculate CRC bits? By applying XOR operation. By applying XOR operation on my data unit, by applying XOR operation, I will calculate CRC bits. How to apply XOR bits guys? XOR bits is also called as modulo 2 sum. This XOR operation is also called as modulo 2 sum. This XOR operation is also called as modulo 2 sum. What it means? Add the 2 points. Modulo 2 sum means add the 2 bits and then divide by 2. Suppose 1 XOR 1. So add these 2. What is 1 plus 1? 1 plus 1 is 2. Divide it with 2. What I get? Remainder is a 0. So the result of 1 XOR 1 is 0. 1 XOR operation 0. The resultant is 1 plus 0 is 1. Divide it with 2. What remainder I am getting? 1. So the resultant of 1 XOR operation 0 is 1. The resultant of 0 XOR 1 would be 1. The resultant of 0 XOR operation 0 would be 0. The resultant of 1 1 1, if I apply XOR here, then 1 plus 1 2, 2 plus 1 3, 3 divided by 2 1. So the resultant would be 1. So resultant of XOR would either 0 or 1. Either 0 or 1. If it is completely divisible by 2, it is 0. If it is not divisible by 2, it would be 1. So this is the functionality of XOR operation. Soumya, you are getting confusing? Don't worry. I am telling you once again. Guys, if you are getting confused, once again I am checking. Once again I am telling you. Guys, I am repeating it again so that no candidate can have any kind of doubt in their mind. No candidate should have any kind of doubt because it is very important topic. Soumya, focus here. My initial data is 1011011. And all the other candidates also please focus. My initial data is 1011011. Now I need to send this data to receiver. But I also need to check that whether my data is sended at the receiver's end correctly or not. So in order to check at the receiver's end that my data is correct or not, what I will do, I will apply CRC technique. CRC simply means that cyclic redundancy check. CRC means cyclic redundancy check. Now how to check it? For applying CRC, we need a CRC generator. This CRC generator you can choose manually. अरे यार, दीपक, guys, I am repeating it again so that you can get it smoothly. You can get it smoothly. I am repeating it again so that you can get it smoothly. Suppose here it is my sender, here it is my receiver. Suppose my sender have a data 1011 011. It is my data of a sender. It is a sender's data and it wants to send this data to the receiver. So for that it can send the data, but I also need to check whether my data is correctly sended or not, whether my data whatever I have sent it from sender to receiver is exactly what sender has sent it or not. For that I use CRC scheme, and this CRC scheme will use CRC generator. It will use CRC generator. CRC generator can be manually be used. Suppose I am using 1101. Suppose I am using 1101 as a CRC generator. Suppose I am using CRC generator as a manually. Just 2 seconds. I am using 1101 as a C generator, guys. And as I said you, this CRC generator is of 4 bits. So I will use 3 bits, that is one less than this CRC generator bits, as a appended bits. So I use 3 zeros as a appended bits. I used it as a appended bits. I used this as a appended bits. अरे यार, दीपक, अरे 2 मिनट आ यार, अरे 2 मिनट जल्दी आ। ये राउटर बंद हो गया यार, इसका वो चार्जर देना, ये ना इसमें लगाओगे, इसका चार्जर दे, ये आईफोन का है यार। ये राउटर क्यों बंद हो जाता है यार बार बार यार। अरे यार, हेलो सर, एक्चुअली डोंट नो, बार बार ये जूम 5.0 अपडेट बता रहा है। जूम इज अपडेटेड टू 5.0, उसकी वजह से ब्राउजर से एग्जिस्ट हो रहा है सर। आई एम ज्वाइनिंग अगेन सर। नो इंटरनेट को बता। Hello guys, am I audible to everyone? Am I audible to everyone, guys? Actually, due to technical problem in June, I am getting these issues. Am I audible to now, guys? Am I audible to now? Due to technical issues in Zoom, as I have previous version of Zoom in my laptop, that is why I am getting such problem. But don't worry, now onwards I will not get such kind of problem. Is it? Am I audible and my screen is visible to everyone, guys? Is my screen is visible to everyone? Please comment me in chat box, guys. Is my screen is visible to everyone? My sound is not my sound. Am I audible or not, guys? Am I audible or not? Please answer me. Am I audible, guys? Guys, what I was telling you, that this is my data. I want to send this data to my receiver. For that I use CRC schemes code. CRC generator I use 1101. This CRC generator is 4 bits. It may be of n bits. If it is of n bits, I will use n minus 10 bits as a appended bits in the right hand side part of this data. So I added these 3 bits as a appended bit, but this is my appended bits. These are my CRC generator bit, but on the place of appended bit I need to add CRC bit. What I need to add on the place of this appended bit, I need to add CRC bits. CRC bits would always be 3 bits. Whatever bits my appended bit would be, I will replace this appended bit with the CRC bits. But the question here is that how to calculate CRC bit. So CRC bits will be get calculated using XOR operation. Using XOR operation, I will calculate CRC bits. Now Soumya and other candidates who have stuck in previously, please focus very clearly here. XOR operation is also called as modulo 2 sum. XOR sum is also called as modulo 2 sum. Means we need to add this 1 plus 1, whatever 1 plus 1 is there, 2, divide it with 2, what remainder I am getting? 0. So the result of 1 modulo 1 equals to 0. Result of 1 modulo 0, that is sum of 1 plus 0 is 0, 1, and divide it with 0. So if you will divide 1 with 0, you will get 1 as a remainder. So 1 would be the XOR result of 1 0, means 1 XOR 0 will be, you can write it like 1 XOR 0 would be 1, or 0 XOR 1 would be 1, and 0 XOR 0 would be 0. Is it clear, guys? Is it clear? Until now, is it clear to everybody that how to apply XOR operation? How to apply XOR operation? Is it clear? Soumya, is it clear how to apply XOR operation? Okay. Now guys, the question here is that need to calculate CRC bits. Now to calculate CRC bit, we need to apply XOR operation between this complete data, that is 1 0 1 1 0 1 1 0 0 0. I need to apply XOR operation of it with the CRC generator. What is my CRC generator? 1101. With the CRC generator, that is 1101 1101, I need to apply the XOR operation of it with the complete data which I have made with the help of CRC bits. So check here, 1 0 1 1 0 1 1, and I added these 3 zeros as the appended bit. I need to apply XOR operation of it with CRC generator. My CRC generator would be 1101. My CRC generator is 1101, and this is the data on which I am applying XOR operation. So if I will apply XOR operation here, guys, 1101, I will apply 1101 here. What would be the result? 1 and 1 XOR, 0 0 1 1 1 0 1 1 1 0, and I will copy the remaining as it is, that is 0 1 1 0 0 0. Is it clear, guys? Again I need to apply XOR operation until I got the remainder. So again I will apply XOR, that is in step 2. In step 2 I will apply XOR operation again, 1 1 0 1. Now the result would be 1 1 0 1 1 0 0 0 0. 0 1 is 1, and I will copy the rest of data as it is, that is 1 1 0 0 0. Now I need to again apply XOR operation. So in step 3 I will again apply from the right hand side bit, because this bit doesn't have any existence. So 1 1 0 1, I will again apply XOR, that is 1 1 is 0 1 1 is 0 1 0 is 1 0 1 is 1 0 0. And in next step I also need to again apply a XOR operation, that is 1 1 0 1. 1 1 is 0, 1 1 is 0, 0 0 is 0, and 0 1 is 1. So the last three bits of remainder, because after this I only remain one bit. In this step I am only have one bit now. So now I can't apply any XOR operation, because I need 4 bits to apply XOR operation with this. So last 3 bits of this remainder would work as a CRC bits. So these 3 bits which I have added as a appendant bits, I will replace it with the CRC bits. So 1 0 1 1 0 1 1, and I will replace this with CRC bits. What are my CRC bits? 0 0 1. So this is the data which I will send from sender to receiver's side. Okay, Checksum is asking that, sir, please tell us division again. Okay, Checksum, focus here. I am telling this division again. I need to apply XOR operation from the data 1 0 1 1 0 1 1 in this appended bit to the CRC generator 1 1 0 1. All the candidates, please focus it again, how to perform this XOR operation division. Simple like you perform division 1 0 1 1, just apply XOR operation 1 and 1. What is the result of 1 and 1? We have take here now, result of 1 and 1 is 0. So just use 0 here. What is result of 0 and 0? We have deducted 0 plus 0 is 0. So we will use result 0, or 0 of 0 is here. उसके बाद 1 and 1 is 0. Okay, 1 0 1 1 is there, no? 1 0 1 1. Okay, it is 1 1 0 1. It is 1 1 0 1. So 0 1 is 1 1 is 0, 0 1 is 1, 1 0 is 1, and 1 1 is 0. And I will copy the remaining bits as it is, that is 0 1 1 0 0 0. So this first step is clear, Checksum? This first step is clear to you or not? That how I perform this XOR operation? I put 1 1 0 1 here, this 1 1 0 1 here, and I applied XOR operation. On applying XOR operation, I got 1 and 1 0, 0 and 1 1, 1 and 0 1, 1 and 1 0, and I copied all the remaining bits as it is. Is it clear? Okay. Now in next step what I will do? I will again apply the XOR operation, but this first bit is of no use because it is 0. So I will leave it, and I will start my XOR operation from here onwards, 1 1 0 1. So you will see here 1 1 is, result of 1 1 is 0, result of this 1 1 is 0, result of this 0 0 is 0, result of this 0 1 is 1, and I will copy the remaining bits as it is, that is 1 1 0 0 0. So I don't have use of these 3 bits now. Is these steps are clear to everybody, guys? Okay, now just focus step by step, you will get clear everything. Now again I will need to apply XOR operation 1 1 0 1, 1 1 is 0, 1 1 is 0, 0 1 is 1, 0 1 is 1, 0 0. So this 2 bit is of no use. Now I will again apply XOR operation on 1 1 0 0, this 1 1 0 0 here, and I will apply XOR operation on 1 1 0 1. So what is 1 1? 1 1 is 0, 1 1 is 0, 0 0 is 0, and 0 1 is 1. So guys, you will see how many bits of how many bits I will use in my CRC bits. I will use 3 bits as a CRC bits. Why? Because my appendant bits are 3 bits, because my CRC generator is of 4 bits. My CRC generator consists of 4 bits. My CRC generator consists of 4 bits. So in CRC bits I need to take 3 bits. So whatever 3 bit I need to start 3 bits from least significant bits onwards. So this 0, 0, 1, I will replace these 3 bits, these 3 significant bits as a CRC bits. So if I will replace this 0, 0, 0 with 0, 0, 1, my sender side's data that will be passed to the receiver would be look like this. Is it clear to everybody? No Saksham, no Saksham. This 0, 0, 1 will be replaced with here. This 0, 0, 0 will be replaced on the appended bit and my data will be look like this. So my data is now 1, 0, 1, 1, 0, 1, 1, 0, 0, 1. Just focus one by one. You will get clear everything. This is my sender side data which I am sending to the receiver. Is it clear? Now guys, the next point is what data I have sent it to the receiver. I have sent it data 1011, 1011, that is 011, 011 and 001, 001. This data I have sent it to the receiver side. Saksham, what you are saying in step 3? That sir, I think only the first 0 will ignored. No. All the zeros on the most significant bits will be ignored. All the zeros, Saksham, all the zeros on the most significant bits will be ignored because they don't have any use. While doing division, we will do the same thing. Okay, so don't worry about it. We will ignore all the most significant bits. Whatever most significant bits are there, we will ignore all that. Now, this is the data. Saksham, is it clear to you? So now this is the data receiver have received. This is the data receiver have received. Now I need to check whether receiver is received correct data or not. So I just need again 1011011001. I will again divide it with CRC generator. What is my CRC generator, guys? My CRC generator is 1101. In CRC generator, sender have a knowledge of CRC generator, that what CRC generator is, and receiver also know the what is CRC generator. So again, the data which is received by receiver will be get JOR operation with the CRC generator, that is 1101. And at the receiver side, if I will divide it, if I will apply JOR operation again, guys, if I will apply JOR operation again, 1101, then what I will get, guys? 11 is 0, 01 is 1, 10 is 1, 11 is 0, and will copy all the remaining step as it is. In my next step, guys, again I need to apply JOR operation 1101. So 11 is 0, 11 is 0, 00 is 1. What I am left with 01, that is 1, and will copy all the remaining bits as it is 11001. These 3 bits, Saksham, will be get ignored. No, Saksham, please focus here. Don't go there. Because on Google, many things are irrelevant. They don't have any kind of authenticity. Just there is a need of authenticity. There are many blogs which are unauthenticated. So don't focus there. Right? Because whenever we will discuss the solution, this is the made easy solution which I am telling to you. This is the solution according to the gate. And after this, you will get each and every step clearly. So in this step, whatever we have on the most significant bit, we need to ignore it. Now what we are left with? We are left with this 111. Now in next step, I also need to perform JOR operation again. 1101. So 11 is 0 again, 11 is 0 again, 10 is 1, 01 is 1, and 01. Now I will again need to apply, I will again ignore these 2 bits and apply JOR operation of this 1101. So if you will apply JOR operation between 1101 and 1101, what you will get? You will get 1 and 1 is a 0, 1 and 1 is a 0, 1 and 0 is a 0, and 1 and 1 is a 0. So what I get? Remainder. I get remainder 0. I got remainder 0. So in receiver side, by applying JOR operation to the receiving data, if I got remainder as a 0, it will prove that I don't have any error in my data. Why? Because I got remainder 0. By applying JOR operation with the CRC generator. This is the CRC method, guys. This is the CRC method. Is it clear to everybody? Is this method is clear to everybody? No, Saksham, it will further lengthier the process. It is further lengthier the process. Don't go on that. This is the correct approach which I am telling to you. You can refer NEPTEL lectures. You can verify it with the NEPTEL IIT Delhi's lecture. Is it clear to everybody or not, guys? The process of CRC. Further, any candidate have any doubt? Please tell me. I will tell once again. Don't worry. Is the process of CRC is clear to everyone? I am asking to all the candidates. Is the process of CRC is clear to everyone or not? Please tell me, guys. If you have any kind of doubt or query, or if you are stuck anywhere, just ask me. I will solve it. I will solve it. So my remainder here is a 0, because after applying XOR operation in the last step, what I got 0, 0, 0, 0. So here remainder is a 0. So this remainder 0 at the receiver side indicates that the data which I have sended, is exactly the data which is sended by the sender. Okay, guys. Okay, focus here. Suppose this bit is get changed now. Suppose this one bit is now changed with 0. Suppose due to electrical fluctuation or voltage change, this bit is changed to 0. So what my data is now? 1 0 0 1 0 1 0 0 1. Okay, it is my data now. So I will apply XOR operation of 1 1 0 1 with data 1 0 0 1 0 1 1 0 0 1. And after applying XOR operation here, what I will get? 1 1 0 1. 1 1 is 0, 0 1 is 1, 0 0 is 0, 1 1 is 0. So I will again copy the same to it and will apply XOR operation again. In second step, 1 1 0 1, 1 1 is 0, 0 1 is 1, 0 0 is 0, 0 1 is 1, 1 1 0 0 1. In next step, 1 1 0 0 1. So here 1 1 is 0, 0 1 1 1 0 1 0 0 1. In next step, 1 1 0 1 0 0, here 1 1 0 1 will get 0 0 0 0. But at last what I get? 0 0 1. So if you will see here, in this step itself, Saksham, focus here. In this step itself, I can say all the most significant bits are 0. Just ignore it. I got remainder 1. I got remainder 1 here. I got remainder 1 here. This will indicate that whatever data receiver has sent have error, because when apply XOR operation with the CRC generator, I am getting remainder as a 1. So I didn't have to get any remainder. If I got remainder 0, means my data is correct. If I get remainder 1, my data is incorrect, because I changed this 1 with 0 and then applied XOR operation. So what my data got? I got 1 as a remainder. So it will indicate that my data is incorrect. So I will retransmit this data again. Is it clear, guys? Is it clear to everyone or not? Please answer me. Is this clear to everyone or not? Please answer me. Good, Saksham. Clear now? Very good, very good. Is it clear to every other candidates? Soumya, Ashik, Manjit, Nikhil, Yash, Rajdeep, and all other candidates. Is it clear to everyone? Okay, last part means this problem. Soumya, are you talking about this problem? Okay, in this third division you couldn't get in green color na? In green color you want to know na? Okay, focus here. Soumya, focus here. Initially I have 1101. Now 1101 is applied XOR. So what I get? 1000110001. I again applied XOR operation with 1101. So I got this 10111001. I again applied XOR operation. So what I get? 1101001. Now in this I again applied XOR with 1101. So in this step, focus here. In this step I applied XOR operation between 1101, 001 and 1101. It is your third step, Soumya.
In this 1 1 is get as 0, 1 1 is a 0, 0 0 is 0 and 1 1 is 0, and copy all the other string as it is 0 0 1. So just ignore all the left hand side bit. What I get? I got only one bit and that is 1. So it is my remainder. That is why I can conclude that my data was incorrect. But if I will get 0 in the last position like that, I can conclude that my data don't have any kind of errors in it. Is it clear to everybody? Is this question is clear to everybody, guys? So I hope CRC is clear to everybody. Good. Good. Totally clear. Very good, Soumya. Now again I am discussing, guys, some important problem. Now guys, if you got CRC, if you got CRC generator in your question, if you got CRC generator in polynomial form, if you got CRC generator in your question in polynomial form, suppose we in question it is saying that x cube plus x plus 1, it is your CRC generator. It is your CRC generator. Then how will you generate CRC bits from it? You will generate CRC bit by rewriting it as 1 into x cube plus, we don't have anything with x square, so we will write it like 0 into x square plus 1 into x plus 1 into x to the power 0. We will rewrite it like this and will conclude that CRC generator bits are 1, that is this, 0, that is this, 1, that is this, and 1. Means our CRC bits are 1 0 1 1. With the help of polynomial, this CRC generator polynomial, we will conclude that our CRC generator bits are this. So guys, if in question they will provide CRC generator to you in polynomial form, you will generate CRC generator bits with this, and these CRC generators are of 4 bits. So how many zeros I will append? I will append 3 zeros, 4 minus 1, and my CRC bits would always be of 3 bits. Is this concept clear, guys? That if in polynomial form you will get CRC generator, then how will you generate CRC bits, CRC generator bits? Is it clear, guys? To everybody? To everybody, is it clear? Please comment me in the chat box. Is it clear to everyone? Is it clear to everyone, guys? Please answer me. In the chat box, please answer me. Is it clear to everyone or not? I am looking for your responses in the chat box, that if you got CRC generator in polynomial form, how will you generate bits? Is it clear to everybody now? Guys, please respond so that I can move forward. Okay, 5-minute breaks you need. Is in front of you now. Question is at sender side. Question is at sender side. The data is at sender side. The data is 11010. It is the data at sender side. It is the data at sender's side. That is 11010. CRC generator. You have CRC generator. X cube plus x plus 1. Receiver have received the data is 1101010. It is the data that is 11010, and it is the receiver side data. You need to answer me, is there any retransmission needed? Is there any error in data packets? Is there any errors in data packets? Guys, answer me. I am giving you 2 minutes. I will not give more than 2 minutes in this simple question. Answer me. Is there any errors in this data packets, guys? I will not give much more time. Okay, Soma, I will tell you that from where you need to read this kind of things. Don't worry. But before that, please solve this question. I am giving 2 minutes. It's 1:10 p.m. At 1:12 p.m. I will solve this question. Use your approach. This is the data. This is CRC generator. And this is the data receiver have received. Is there any errors in data packets? Please answer me. Is there any error in data packet? Yes or no? Please apply all the approaches and concepts which I have told you. No error. Very good, Yash. Shivang, please verify. Shivang, please verify. Please verify the solutions, Shivang. Guys, just 30 seconds more and then I will discuss the solution of this simplest question. Just 30 seconds more. No error. Very good, Soumya. Soumya is finding error. Remainder 1 is coming. How? Okay. Okay, I will tell you the solution. Don't worry. I will tell you the solution, guys. Don't worry. Just 10 more seconds, guys. I am requesting all the other candidates as well. Answer me that is there any error in data packet at the receiver end? This is the data at receiver end. This is the original data. And this is my CRC generator. Is there any error in data packets? No error. Okay. Now see the solution, guys. See the solution. My original data is 11010. It is my original data, guys. What my CRC generator is? CRC generator is x cube plus x plus 1. I can rewrite it like 1 into x cube plus 0 into x square plus 1 into x plus 1 into x to the power 0. So what is my CRC bits? CRC generator bits 1 0 1 1. It is my CRC bit, isn't it, guys? These are my CRC generator bits. So how many zeros I will add? I will add 3 zeros as a appended 0. As a appended 0 I will add 3 zeros. Okay, guys? Yes, 100 is a CRC generator bits and I will add 3 zeros as a appended bit. So how my data will look like? 11010 and these 3 zeros. This is my appended bits data. So this data will send it from sender's side. So focus here. What is my data? 1101 1101, then 0000 1101 and then 0000. And what is my CRC bits? 1011. It is my CRC bits. So 1011, it is my CRC bits. Just apply XOR operation. Just apply XOR operation. 1011. What I get? 11 is 0. 10 is 1. 01 is 1. 11 is 0. Copy all the remaining bits as it is. Focus on the next step. Again apply XOR operation. In second step, 1011. So 11 is 0. 01 is 1. 01 is 1. 01 is 1. 000. Again apply XOR operation, guys. Again apply XOR operation. 1011. So 11 is 0. 10 is 0. 11 is 0. 01 is 1. And copy all the remaining string as it is. 01 is 1. 11 is 0. 10 is 0. 11 is 0. So guys, if you will see here, guys, okay, it is 1. 10 is 1. 10 is 1. 11 is 0. 01 is 1. 00. Again apply. Means there is a need of again apply XOR operation. 1 0 1 1. Again apply XOR operation. What I will get? 1 1 is a 0, 0 0 is 0, 1 1 is 0, 0 1 is 1, and 0 is 0. So 3 bits, least significant 3 bits, that is 0 1 0. It is my CRC bits, guys. It is my CRC bits, isn't it? It is my CRC bits. 0 1 0 is my CRC bits. So I will replace 3 zeros with CRC bits. That is 1 1 0 1 0 and 0 1 0. It is my CRC bits. The data which is sent to the receiver is this. So just match this data with the data which sender has sent. Sender has sent the data 1 1 0 1 0 0 0. And in question itself it is written that receiver has sent the data 1 1 0 1 0 0 1 0. And what sender will send? Sender will send 1 1 0 1 0 0 1 0. So this data and this data is same. This is the data which sender had sent to the receiver after applying CRC bits, and this is the data which is receiver have received. So both this data is looking exactly. That is why no error. That is why no errors. Is it clear to everybody, guys? Is this solution is clear to everybody? Clear? Comment me. Is this solution is clear? Yes, Manjit, we can further check by applying XOR operation with the CRC generator bit in that. If we will get remainder as a 0, then we will say that no error. And if we will get anything as a remainder, but there is no need to apply anything XOR operation on receiver data, because we can manually check. Computer is not checking. We can manually check this data, and our questions data is same. That is why no error. Is it clear to everybody, guys? Is it clear to everybody? Very good. Clear to everyone. Very good, guys. Very good. Now this is the question you may face in your GATE exam, guys. Answer it. Out of option A, B, C, D, which of the following is correct answer? The question is, let Gx be a generator polynomial used for CRC checking. What is the condition that should be satisfied by Gx to detect odd number of bits in the error? Out of A, B, C, D, just answer me which of the following option is correct. Answer me, guys. Which of the following option is correct out of A, B, C and D? Yes, C. Okay, good. Manjit, very good. Guys, let's see the solution now. The question is, Gx be the generator polynomial used for CRC checking. What is the condition that should be satisfied by Gx to detect odd number of bits in error? Option A, Gx contains more than 2 terms. Unnecessary argument. No need to focus on it. No meaning. Gx does not. Option B, Gx does not divide 1 plus x to the power k for any k not exceeding the frame length. We didn't have discussed this point yet. This is nothing point. This is in no relation with our topic. False. Option D, Gx has an odd number of terms. We didn't talk about even and odd here. 1 plus x factor of Gx. You can scan options, and by scanning, by making other statement false, you can itself find what is the true option. Option C is the true. 1 plus x is a factor of Gx. I already told you that CRC bits are 1 bit less. So CRC bits plus 1. CRC bit plus 1, it is a factor of Gx. So option C is the correct answer, guys. Next question is in front of you now. The next question is in front of you. The message 110, 010 and 01 is to be transmitted using CRC polynomial. Using CRC polynomial x cube plus 1. It is nothing but x cube plus 1. To protect it from error, the message that should be transmitted is, what message should be transmitted, guys? Answer me now. Very important question. What message should be transmitted to protect it from error? Soma, previous question, focus here Soma. X is nothing but the CRC bits. If we will add one bit to it, it should be factor of gx. Means we are talking about this one. That after adding one bit to the CRC bit, it should be the factor of this one. That is, this is the CRC bit 3. And CRC generator is one more bit than this CRC bits. CRC generator is one more bit, and it should be exactly divisible by this. It should be factor of gx. So 1 plus x means CRC bit plus 1, that is CRC generator is a factor of gx. If it is a factor of gx means remainder will be 0. So that polynomial can be used. Clear Soma? That 1 plus x is a factor, means 1 plus x का means ये है. What does 1 plus x? That CRC generator should be factor of gx. So 1 plus x is factor of gx means it would consider your remainder as 0. So it will detect odd number of errors if there exist any kind of errors. If it is a factor, no problem. It is not factor, then there is error. Good. Now the next question is in front of you guys. This is the message. CRC polynomial is in front of you. And to protect it from errors, the message should be transmitted as. I am giving you 2 minutes. Guys, I am giving you 2 minutes. Please answer it. Please answer it fastly. Out of A, B, C, D, which of the following option is correct? If this message, that is 11001001 is to be transmitted using CRC polynomial to protect it from error. Okay, Poshali. Requesting all the candidates to answer. Poshali has answered, Ashik has answered, Yash has answered. Requesting all other candidates, please take part in it. Manjit has answered, Yash again has answered. Okay. Guys, to protect it from error, what concept you will use? You will add CRC bits. You will add CRC bits in the list of significant bit side. Means in right hand side you will add CRC bits. So what are CRC generator? My CRC generator is 1 into x cube. Focus on the solution, guys. I am telling you solution. 1 into x cube plus 0 into x square plus 0 into x to the power 1 plus 1 into x to the power 0. So what is my CRC bits? CRC generator bits. 1001, 1001, 1001. It is my CRC generator bits. It is my CRC generator bits. Now my message is 11001001. It is my original message. 11001001. It is my original message. I will add 3 more zeros as a appended bits. Why? Because CRC generator have 4 bits. So I will add 3 zeros in the right hand side of this. And then I will apply XOR operation with CRC generator. CRC generator is 1001. So with 1001 I will apply XOR operation. See here, 1001. 11 is 0, 10 is 1, 00 is 0, 01 is 1. And copy all other as it is. 1001 000. In next step, again apply XOR operation. 1001. So 11 is 0, 00 is 0, 10 is 1, 11 is 0. Copy all other as it is. 00 1000. Again apply. In step 3, 1001. So 11 is 0, 00 is 0, 0 is 0, 01 is 1, 1 is it. Copy all as it is. Now in next step what I got? 11000. These bits I have. Now I need to apply XOR operation once again. So 1001. So if I will apply 11, it is 0. If I will apply 10, it would be 1. If I will apply 000, 01 is 1 and 0 as it is. I need to apply XOR operation once again. 1001. So 11 is 0, 0 is 0, 10 is 1 and 01 is 1. So I need to replace this. I need to replace this appended bits. I need to replace this appended bits with this CRC bits 011. If I will replace it with 011, how my data will look like? 1100 101 and 001. It is option B. Option B is the correct answer, guys. Is it clear to everybody? Is it clear? Huh? Yes, na? It is transmitted. So this will transmitted, na? Message will transmitted after applying CRC bits. After applying CRC bits, message would transferred, and receiver will receive this message, and receiver will again apply JOR operation with 1001. If it will get 0 as a remainder, it will be error free. So this message will be transmitted. This message will be transmitted as a transmission from sender side. Is it clear to everyone? Is this clear to everyone, guys? Very good, very good, very good, guys, very good. Now option B is the correct answer. Now, guys, a short topic here is the checksum. So focus here. What is checksum? In sender side, if m bit checksum is used, the data unit to be transmitted is divided into segments of m bits. So basically checksum is done in the similar way as we have done CRC, but on the place of CRC generator bits and CRC bits, in checksum what we do, we just divide the data, sequence of data, right? Suppose I have sequence of this data like this. Suppose I have sequence of data like this, and I need to apply 8-bit checksum. 8-bit checksum. We can use 16-bit checksum. We can use 32-bit checksum. It depends on the condition which is given in the question. That what condition it is given in the question, on this basis we will perform the checksum. So suppose this is the sequence of my data. So in this sequence of data, I have divided this sequence of data in exactly 8 bits, 8 bits, 8 bits, 8 bits, 8 bits, 8 bits, and so on. Okay, so all the m bit segments are added. The result of the sum is then complemented using 1's complement. So the step 1 is you need to divide all the data into 8-bit segments, and suppose you will get something. Suppose there is a value like 000011010. So it is nothing but the decimal value of 0001010 is 10. Suppose the decimal value of this is a 10, and you will get decimal value from here. Suppose 1, you will get decimal value here from 2, you will get decimal value here from 6. You can get anything as a decimal value. Suppose here from 7, you get decimal value here 11. So you need to add them. You need to add them up. You will add them, and what you will get? You will get 10 plus 1 is 11 plus 2 13 plus 6 19 plus 7 26 plus 11, that is 37. 10 plus 1 11 plus 2 13 plus 6 19 plus 7 26 plus 11 37. Then you will take 1's complement of it. What is 1's complement of it? 1's complement is minus 37. So you will use this minus 37 as a checksum bits. As a checksum bits in the relevant entry. In checksum you will use minus 37. You will add this into the data and then send this data to the receiver. And then send the data to the receiver. This is the checksum method. This is the checksum method. Guys, clear what steps I had told to you? Suppose whatever sequence you are getting now, 0 0 1 1 0 1 0 1 0 1, and suppose I said that perform 8-bit checksum. So divide the bits, 8 bits, then 8 bits, then 8 bits, then take the decimal value of that 8 bits and add them. Whatever you will get as a decimal value, take 1's complement. This is the steps. That result of sum is then complemented using 1's complemented arithmetic. The value so obtained is called checksum. This value minus 37, it is called as checksum. Soumya, focus here. Soumya, please focus here. Focus here. I am telling you again. Soumya, focus here. suppose it is my data. Suppose my data is like 0 0 0 0 1 0 1 0 0 0 0 0 0 0 0 1 0 0 0 0 0 0 1 0 and like that. So in checksum, suppose I had said perform 8-bit checksum. Perform 8-bit checksum. So you will divide your bits into 8 bits. In the group of 8 bits from the left hand side, you will divide it. So it is 8-bit data, it is 8-bit data, it is 8-bit data and so on. You will divide it in the group of data of 8 bits. Is it clear, Soumya? Step 1. Step 1 is clear to all. Step 1, that in step 1 what we need to do. Is it clear? Comment step by step. Yes, 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 so that I can move forward. In step 1, just group into the bits of 8, in the group of 8 bits. Step 1. Clear to everybody? Good. In step 2, take decimal value of it. What is decimal value of it? 10. In step 2, take decimal value of it. What is decimal value of it? 1. What is decimal value of it? 2. Suppose decimal value of it is a 3. Suppose decimal value of it is a 7. Suppose decimal value of it is a 10. Like that. Now you need to add it. You need to add it. You need to add it. If you will add it, 10 plus 1 is 11 plus 2, 13 plus 3, 16. 16 plus 7, 23 plus 10, 33. You will get 33 by adding them. Is this step clear until now? Is this step clear until now, guys? Okay, good. In step 3, take one's complement. Take one's complement of result. Whatever result you got, take one's complement. So one's complement of 33 is nothing but minus 33. So just add it into the checksum field. Wherever checksum field is there, just add minus 33 to that, and then send this data to the receiver. This is the checksum process, guys. This is the checksum process. All these 3 steps are clear to everybody? All these 3 steps are clear to everybody now? Good. Okay, Ashik is saying, sir, repeat it once. Ashik, focus here. In checksum, suppose you have so many number of bits in data. So you will divide it according to the checksum bit. Suppose it is 4-bit checksum. So you will divide it according to the group of 4-bit, 4-bit, 4-bit. But suppose I am saying that divide it into the 8-bit checksum. So in 8-bit checksum, you will divide it like that. You will group all the bits from the left hand side to right hand side in the group of 8. Right? So you will divide it like that. In step 2, you will calculate the decimal value of that and will add that. So after calculating decimal value of each 8 bits, you will add them. And in step 3, you will get one's complement. And then this one's complement value will be added to the checksum as a minus 33. And this will further process, and this will passed to the receiver. And receiver will again group them into the 8 bits and will check that what result is. It is the process, guys, of checksum. Clear now? Soumya, complement will go into the checksum. If checksum is at the last point, it will be there. If checksum is added in the middle, checksum will be there. So wherever checksum field you have, you will add the value of that checksum. You will add this result, one's complement, into the field of checksum. It may be in the front of side, it may be in the middle, it may be in the last. Depend on the question, depend on the data, and depend on the whatever bits we are sending. Depend. Is it clear? Rana is saying, sir, what if bits are not in multiple? Very good question, Rana. Very good. Very good. So focus, guys, here. Focus. Suppose your bits at the last, you got bits like 1 0 0 1, 1 0 0 1, and 1. Guys, focus here. Suppose at the last process, suppose at the last you got 9 bits. You got 9 bits. So what you will do? At the 9 you will take this 8 bits. From right hand side you will take 8 bits, and this 1 will got added to this. This 1 should be added here. You will add this 1 to here. Now it will be 8 bits. So if you will got 9 bits, 10 bits, you just add to the last segment, and whatever result will be there you will use here. It is called as wrap around concept. I hope you know about it. Wrap around. You need to wrapping around whatever extra digits or bits are you are getting. You will wrap around. You will wrap around and make it in 8 bits. Is it clear, guys? Clear to everyone? That if you are not getting digits in the last place in the multiple of 8, you will wrap around. It is clear? Very good, guys. Guys, just take a one question on checksum. Just take one question on checksum so that concepts may be clear to you. Just take one question, guys. Ashik, you will not get you will not get that. If you will add that, you will not get that. Just try. Okay, Poshali is saying, sir, repeat it once again. Poshali, just focus here. Just focus here, Poshali. Just focus here. Suppose that my data is 0, 0, 0, 0. Okay. Ashik, you again focus here, and Poshali both, because they are facing down. 1, 1, 1, 1. 1, 1, 0, 0, 1, 1, 1, 1, 0. Okay, guys. This is my data. This is my data bits. This is my data bits. Now I said to you that you need to perform. What you need to perform? You need to perform checksum using 8-bit checksum. Using 8-bit checksum, perform. So what you will do? 1, 2, 3, 4, 5, 6, 7, 8. This is the group of 8. 1, 2, 3, 4, 5, 6. But you are left with 9. So what you will do? What you will do, guys? You will add 1 to here. So what is the decimal value of this, guys? Decimal value of here is a 15. And after adding 1 here, what you will get? 0 and 1 is 1. 1, 1, 1, 1. 0, 0, 1, 1. Right? Okay, guys? So if you will add 1 here, what you will get? This one. Now what is the value of this, guys? What is the value of this? Whatever the decimal value will be there, right? It's a 0, 1, 2, 3, 4. 5 means 32 and 6. 6 means 64. 32 plus 64. 6 and 9. So 255, 96. So you will get 9, 5. Is it 159, guys? Is the value of this is 159? Is the value of this is 159? You will add this one here. Okay, so you are remaining with this 100 na. So okay. If you will add this one here, you will get this one. Now what is the value of this, guys? Whatever with the value, suppose it is 159. Then you will add 15 plus 159. Then 159 plus 15. 174. So you will take complement of this and will add the decimal value of 174, suppose at the last position. So it will be transmitted as a message. Is it clear, Poshali and Ashik? Because the whatever you will add 1 here na, 159. So if you have 8 digits, we have the range of 8 digits from 1 to 255. So it will be always be under this. Ashik, whatever you will add, it will be in the range of 1 to 255. So it will always be in this side. So we will add that here. Is it clear to everybody? Very good, guys. Very good. Okay, Soma is asking that what if we have 1 1 1 1 1 1 1 1 and 1. it is Soma's question that at last position if we have this, just add 1 here. Just add 1 here. What you are getting? 1 plus 1 is a 0. If you are getting again 9 bits, again add 1. You will repeat this process until you get 8, guys. Soma, clear? Soma, you need to repeat it. You need to repeat it again and again. You need to add 1. If you are getting, you need to add 1. Basically, in real problems of GATE, you will not get such question. In real problem of GATE exam and other CS exam, you will not get such problem. But for conceptual point of view, is it clear? Okay. Next question is in front of you, guys. Consider the data unit to be transmitted. And this is the data unit is in front of you. Consider 8-bit checksum. What you need to consider? 8-bit checksum. So I am telling this question, guys. I am solving it for you so that you can get clarity. We need to perform 8-bit checksum on it. So guys, this 8 bits data, what is my data? 100. That is my data is 100 11 001 111 000 10 00 10 0010. Just 2 seconds. 0010 010 and 1000100. It is my data, guys. So what I said in my question that we need to consider 8-bit checksum. So 8-bit checksum, if I will apply 1 2 3 4 5 6 7 8. So it is my 1 8-bit data. 1 2 3 4 5 6 7 8. It is my another 8-bit data. 1 2 3 4 5 6 7 8. It is my another 8-bit data, and 1 2 3 4 100 4 zeros are there. Okay, 4 zeros are there and 1 0 zeros and 5. Okay, so it is my 8-bit data. 1 2 3 4 5 6 7 8. Okay, so this is my complete data, guys. Now I need to add them. By adding decimal value, I will get, so I can directly get this. If I will add this, that is 10010, that is this one, plus this one, that is this one. If I will add this to this one, and if I will add this to this one, I will get this as a resultant. I will get this as a resultant. Guys, focus here, focus here. So if you will observe here, it is 10-bit data. So now you got clear. You got clear that 001011, that is from right hand side. From right hand side, I will consider 8 bits and will add this most significant bits 10. The most significant bits are added to it. So after adding most significant 2 bits, I get this data. I got this data. So this is, and I will take 1's complement of this now. I will take 1's complement. So after taking 1's complement, I got this. So this is my checksum value. This is my checksum value, guys. What is my checksum value? This is my checksum value. What is my checksum value? Checksum value is 110111010. It is my checksum value. And what data? The sum of all data. What is sum of all data, guys? Sum of all data is 00100100101. It is my sum of all data. It is sum of all my data. So this is sum of all my data, and this is my checksum. If I will add checksum and sum on receiver side, I must get 1111111 like that. 1111111. If I will get 11111, then I will complement this value again. So I will get 00000. Since the result of this complement is 0, so receiver will assume that no error occurred at the data and therefore accept it. Is it clear? The concept of checksum is clear to everyone. Whatever checksum we will get, we will add with the sum value. Our sum value, we will again complement it, and if we get 0 as a result, we will say that no error is there in the data at the receiver's end. Is it clear to everyone, guys? Is this clear to everyone? Because it is very important topic. CRC and checksums are very important topic under error detection, and only these two topics are there which you need to understand for GATE perspective. Is it clear to everybody or not? Please answer me. Further, if any candidate have any kind of doubt, please ask me. Clear, crystal clear. It should be very crystal clear to all of you guys. It should be very, very crystal clear to all of you. Manjit, it will be same. If we will take value in decimal, then again we need to convert it into the binary, because our process is in the term of binary. So I told you to convert in decimal just for the sake of understanding, just for the sake of clear understanding, I told you. But if you will convert this and then add, it is similar that you will add the binary value of that, because if you will add 10 plus 2 in a decimal, you will get 12. If you will add binary value of 10 and binary value of 2, you will again get 12. So no need to get it, because compiler and computer will do on my binary language like that. But on the perspective of decimal, I told you just for sake of understanding. Clear to all of you guys? Is this concept is clear to all of you? CRC and checksum, very, very important topic that you may face in your GATE 2021 exam. Very, very important, guys. Yes, so in the receiver side, after adding checksum and sum, you will get all bits 1 1 1. It itself is that after taking complement of it, you will get 0. So after adding checksum and sum value of these digits, if you will get all the bits as a 1, means no error. If you will not get all bits as a 1, suppose your bits at the end is 1 1 1 1 0 1 1 1, means there is a error. Why? Because if you will take complement of it, it would be 0 0 0 0 1 0 0 0. So complement of this result of checksum plus sum at the receiver end should be 0. If it is not 0, means error is there in the receiver's end. Is it clear, Soumya? And every other one? Is it clear to every candidate? Is this problem is clear to every candidate or not? Please answer me, guys. Checksum is clear to everyone or not? Please answer me, because it is very important and you may face some important problems in your GATE exam. In your GATE exam, you may face some important problem in that. Sir, sum E are considering the sum of each 8 bit. But what is checksum distinctly? Checksum is the ones complement. After adding this 2, checksum is ones complement. Checksum is ones complement and it is 8 bit data. Whereas sum is without one complement data. Your sum is 8 bit data without complement. Whereas checksum is one's complement of that 8 bit data. Is it clear, Soumya? What is the difference between these two? Your sum is 8 bit data of sum after adjusting these bits like 2 bits and that. And if you will take one's complement, then that would be considered as a checksum value. So checksum value will always be one's complement of the sum. Yes. It should always result in 0. If it will not result in 0, means there is somewhat changes happened in meanwhile transmission. That is why we can detect that error is there. So our aim that we need to detect that there is error or not, we can detect it with checksum, because if sum is not 0, we itself can derive that there is error. Is it clear, guys? Yes, Soumya. Checksum is one's complement of sum and it should always be 0. If it is not 0, means meanwhile transmission, maybe due to any reason, due to power fluctuation, due to thunderbolt, bits are changed and we can easily detect that there is error in receiver's end. Clear to everybody, guys?